So in this video we're going to look at a second exam question on inferential stats. So we'll work our way through the question as usual. We're told it's normally distributed, the weights of ostriches. So the weights of the females have a mean of 78.6, standard deviation of 5.03 kilos. Then for the males have a mean of 91.3, a standard deviation of 6.29. So our question is to find the probability that a randomly selected male will weigh less than 80. So they want the probability that x is less than 80. We need to get a z value. So from your log tables, that's x minus mu over your standard deviation. The x value is 80. The mean weight for the males was 91.3. The standard deviation is 6.29. Into our formula, we get 80 minus 91.3 over 6.29. Into your calculator, 80 minus 91.3 divided by 0.29. Quite a long decimal, minus 1.79. 6502385. Now we've seen in earlier videos, we're going to round this firstly, and then secondly we'll deal with the fact that it's negative. Okay, so we're looking for the probability that z is less than minus 1.80. We don't deal with negative numbers, so we flip our sign and flip the inequality, so it'll be greater than 1.80, which we know we can't figure out, so it's 1 minus the probability that z is less than 1.80. So we'll go to our log tables for our 2 pages of z values. Check up left column 1.8 and then your top column 0.00. We get 0.9641. Into your calculator and we get back 0.0359. So our answer then is 0.0359, or else 3.59%. Okay, and that's part 1 answered for 10 marks. Part 2, find the probability that a randomly selected female will weigh less than 80 kilos. So it's the probability that x is less than 80. We need our z-score. My x value is 80. My mean for females, they said, was 78.6. And the standard deviation for them is 5.03. So we get z is equal to 80 minus 78.6 over 5.03. Into your calculator. 80 minus 78.6 all over 5.03. Quite a long decimal. Z is equal to 0.27833000199. We'll round to 2 decimals. And we get 0.28. So we want the probability that Z is less than 0.28. Straight to our log tables here. We get 0.6103. So our answer then is 0.6103 or 61.03%. Okay, part 2 answered for 5 marks. Part 3 now. So find the probability that a random selected female will weigh between 70 and 80. So what's happening here is we'll have 70 less than x less than 80. So we'll draw a quick sketch. So we have our normal distribution. There's 80, there's 70, and we're being asked to find this area in between. So what we'll do then is we'll find the probability that x is less than 80 and subtract the probability that x is less than 70. Now we know from part 2 we have figured out less than or equal to from part 2, we have figured out the probability that Z is less than 80. It's the same difference as being less than or equal to, so that's fine. So we're just working out this second part. So we'll need a Z score, it'll be x minus mu over the standard deviation. X value is 70. The mean for the females 78.6, and our standard deviation is 5.03. Into our calculator, 70 minus 78.6 all over 5.03. We get minus 1.709741551. Tidy up to 2 decimals. So that's minus 1.71. We need the probability that Z is less than or equal to minus 1.71. Flip our inequality, flip our sign. So it'll be 1 minus the probability that Z is less than or equal to 1.71. Go to our log tables and we get 0.9564. Into your calculator. We get 0.0436. So this here was the second part. And the first part we had found in the previous question. So it'll be 0.6103 minus 0.0436. Into your calculator. We get 0.5667 or 56.67%. Okay, so part 3 answered for 10 marks. These types of questions where you have an inequality, always make sure you draw a quick sketch. It'll help with your solution. Okay, part B now. We have 20% of females weigh less than T. Find the value of T correct to 2 decimal places. So we'll draw a quick sketch here. So what's happening is they've given us the point T. It's only 20%, so it's a very small area. So that's 0.2. And then we know if we have 0.2 there, the remainder here is going to be 0.8. So we'll use that to help us answer the question. So the probability that Z is less than T is going to equal 0.2. So we need an X score for this. We have a little bit of work to do in between, but we'll set up for a Z score anyway. So it'll be X minus mu over the standard deviation. The X value I don't know, it's T. My mean for the females was 78.6. and a standard deviation of 5.03. Okay, so this is where our 0.8 now will come into play. So the probability that Z is less than T is going to equal to 1 because the whole area here is 1 minus the probability that Z is less than or equal to 0.8. So for our 0.8 now, we go to our log tables. I'll pull these up on the screen now. Give me 1 second. Okay, so we've gone to our log tables and we are looking for 0.8. So we scan our values in here. Now we're pretty close here and we've just gone past 0.8 here. So what we'll do then is we'll take both of these values and work with them, and then between the two answers we'll have a more accurate result. So that gives us back that Z is equal to where are we? Minus 0.84, or else z is going to equal minus 0.85. And the reason we've gone for the minus signs is our mean sit here somewhere in the middle roughly, and as we've moved to the left we're looking at negative values for our z-scores. Okay, so now we come back to our z formula and we have our two cases. So we get minus 0.84 will equal t minus 78.6 all over 5.03 cross multiply by 5.03, and the minus 78.6 on top we can bring over. So our answer for t, we have minus 0.84 multiplied by 5.03 plus 78.6. Give me back 74.3748. There's my first case. My second one, we had minus 0.85. It's going to equal to same numbers again. To get minus 0.85, we bring across 5.03, and then we add on 78.6. Into your calculator. You can just swap out on your previous one the 0.84 for 0.85. We get t equals 74.3245. Okay, so our answer then correct to 2 decimal places. At the end for t, you can pick either solution, or what we can do is add them together. 748 plus 74.3245 and divide by 2, and we'll get 74.35. Around. Kilograms then, because it's weight. Okay, that's that question for 5 marks. So a little bit more awkward approach, but again, once you drew your sketch, it wasn't too bad to answer. Okay, part C, they tell us the middle 90% of the males weigh between A and B. Find the values of A and B correct to the nearest kilo. Okay, we're going to draw a quick sketch. So we're between A and B, and they tell us that this here is going to equal 0.9. So by symmetry then I have 0.05 left either side of the middle 90%. So what we'll do is, using symmetry, we'll figure out that we want the area greater than 0.95. I'm going to go to my log tables here. I'll bring in the second page. Give me 1 second again. Okay, so we have our log tables. We're scanning our values again. We're looking for 0.95. Okay, we're almost there. Here we go, we have 0.95. So if we come back up, that gives us 1.65. Okay, so we're going to use this now to work backwards to figure out our A and B values. So like earlier on, same idea, we'll have 2 scenarios. So it's a z-score, and then for our x value we'll have B and we'll have A. Now A is going to be a negative value. For B we take a positive. The mean weight for the male ostriches they gave us back at the start is 91.3, and a standard deviation of 6.29. Okay, so we have our 2 cases. So we'll have a plus 1.65 here. Over here we have minus 1.65. Same idea for our test statistic when we get plus 1.96 minus 1.96. So our two cases, we get 1.65 will equal to b minus 91.3 over the standard deviation. So we get 1.65 multiplied by 6.29 plus 91.3 will equal b. All of that goes into your calculator. So 1.65 by 6.29 plus 91.3 will give me back 101.6785. And then for my a value, we know it's minus 1.65 will equal to a minus 91.3 over 6.29. Cross multiply by 6.29, bring over your 91.3. That equals a. Enter your calculator. Again, you can just go to your previous sum and swap out your plus 1.65 for minus 1.65, and we get a is equal to 80.9215. Correct to the nearest kilo. So for A we have 81 kilos, and for B then we're going to get 102 kilos. Okay, and that's that question answered. Again, same as the last couple, always draw a sketch, especially if we're dealing with intervals. And because the data is normally distributed, most of the time we'll be able to use symmetry to help us answer our questions. Okay, and at the end now, we're finishing off with some z-scores again. So they tell us there's 82% females, 18% males. One is selected at random. What's the probability that an ostrich weighs less than 80? They want the answer as a percentage, correct to one decimal place. So what's happening here is, we know from earlier we found the probability that a female weighs less than 80 kilos was our part 2 is 0.6103. So we'll work in percentages here. So 61.03%, and then the probability that we have a male weighing less than 80 kilos. Come back up. Was our first part, so we got 3.59%. Okay, and they tell us then in this field that we have 82% of them are females. So we get 61.03% multiplied by 0.82, and then we're going to add to that the probability of a male ostrich weighing less than 80. So we'll get 3.59%, and they tell us there's 18% males in the field. Okay, into your calculator. 61.03 multiplied by 0.82 will give us 50.0446, and we have 3.59 times 0.18 will give me 0.6462. Add the two of them together, and then we'll round our answer. We get 50.6908. We were asked for one decimal place, so that's 50.7%. Okay, so a probability question at the end really, but you needed your z-scores to be able to answer it. Okay, so that's that question done, 50 marks overall.